facts about functions, 1-7A. You will need to follow along with your worksheet as we'll be going over the answers so that you can go on to 1-7B on your own. So just for a brief review, a function is a relation, but it has two special things about that relation. And of course, relations, relation is, it can be expressed with ordered pairs, x, y. It could be expressed with a mapping, where you have two sets and you map 1 to 1. It can be expressed with a table, where you have an in and an out. And it can be expressed by taking this in and out, these ordered pairs, and graphing them on the coordinate plane. But a function has a relation that is not only a verbal or word problem, but a verbal or word problem that has a dependency, where one quantity depends on the other. And it has something that a relation does not. It has a process or a rule where we can write y equals or f of x equals some rule or process to make that function. So a function is a relation, but it's a special kind of relation that has this dependency that's a verbal dependency, because a relation can be verbal, but it has to have a verbal dependency and a process or rule. So how do we identify a function looking at coordinates, x and y? Well, we have to know that when you're looking at coordinates, if you want to tell if it's a function and not just a relation, we cannot have any repeating x values. So no repeating x's. Okay, so look at A. We have 3, 2, 3, 3, negative 2, 0, 0, negative 1. Well, that 3 and that 3, those are repeating x values. So this is not a function. It's just a relation. But now we'll look at B. It has 3, 2, 4, 2, negative 2, 3, and 0, 0. Well, there's no repeating x values in that I don't have any numbers that repeat, so it is a function. So I'm going to put yes. I'm actually going to put yes on this one. This one is a no because of these two 3's right here. And this one is a yes. There's no repeating x values. So when you explain, write no repeating x's. So we go down to C and we look at this mapping. Here's a mapping where we have a 3 mapped to a 2, so 3, 2, and then we have a 3, 3. Well, that's what that's mapped to. It's mapped to two different y values, so that is not a function because there are repeating 3's. Now let's look at D. D has 3 mapped to a 2, and it has 3, 2, and it has 4 mapped to a 2. Is that a repeating x value? No, it's a repeating y value, and that's okay. So on a function, it's okay to have repeating y values. So that's yes, it is a function. Okay, because there's no repeating x values. Now let's go to our t-chart or our in and out chart on E. On E, we have negative 2, 0, 0, negative 1, 3, 2, 3, 3. Whoa, there's two 3's over here, so that's a big no. Let's look at F. F is negative 2, 3, 0, 0, 3, 2, 4, 2. That one's a yes. It is a function. Now let's examine the graphs. If we look at a graph and try to see if something's a function, well, this graph G, I can see that there's a couple of 4 points plotted. There's a negative 2, 0, there's a 0, negative 1, there's a 3, 2, and there's a 3, 3. Whoa, there's those two 3's again. and they fall right in a line. So this one is not a function because it has two repeating x values. So when you explain that, make sure you write it down, repeats the 3's. On h, we can see we have those 4 points we've been working with before, which is negative 2, whoops, need to undo that, okay, negative 2, comma 3, and then it has a 0, 0, and then it has a 3, comma 2, and it has a 4, comma 2. Well, there's no repeating x values. They have repeating y values, so it's okay if it falls in the same y value. So this one is yes. So looking at these two, g and h, what can we say about the graph of a function? A graph of a function must pass what I call the vertical line test. Okay? It must pass the vertical line test. G does not pass the vertical line test, but H does pass the vertical line test. Well, we'd say it passes for our explanation, and I like to just draw the vertical line test. This one, it does not pass the vertical line test, and you could say no, it doesn't pass the vertical line test. On number 2, let's see if it's a function by looking at the domain and range. That's the x and y values. Well, let's look at the domain because it's the x values we don't want to repeat. So we've got a negative 4 here, a 5, a 0, a 1, an 8, and negative 2. Are there any repeating x values? No. So we would say yes, it's a function. There's no repeating x values. No x repeats. That's the easiest way to write that. Then I go down to 3. There's a table of data. Let's see if those are a function. Do you know which side to look at? The independent or the dependent? The domain or the range? Well, let's see. Is it a function? I'm just going to look at the x values. That's the seconds. And I want to see if it's a function. Decide for yourself. I'll be checking this one. On number 5, A, for this relation y equals, determine if it's a function. Identify the independent and dependent, which we didn't identify on the other ones. I'm kind of skipping over that. Identify the independent and dependent variable and state the domain and range. Again, I skipped over that on the last two. We'll do this and when we go over the answers. And it says graph the relation. Well, I'm more interested in you graphing the relation and identifying if it's a function. So I want you to put this into your calculator. And when you put it in your calculator, then I want you to go to the table. So on your calculator, put in y equals, and then just type in 2x minus 3. Well, you're going to ask me, where's the x button? The x button is, you're going to put in 2, and then there's a button that has like x, theta, n, and a t on it. So that's the button that'll put an x in your calculator. And then you're going to go down to minus, and don't use the negative, and then put 3. When you put this in your calculator, you're going to look for the button that will give you a table of values. That button is up on the top row, and that is on second graph. That'll give you a table. When you get your table, I want you to write down your x's and your y's on this paper. So then you can go and graph those x's and y's. How many x's and y's do you need? Well, I would certainly pick at least 3 x's and y's. So get 3 x's and y's for both tables on 5A and 5B. Graph those on this graph. And then I would see if they pass the vertical line test. And if they pass the vertical line test, then you can state if they are a function or not a function. And then we'll go over in class together the independent, dependent, the domain, and range. Don't let me forget, because you know I will. So, to sum up, compare and contrast the characteristics of relations and functions. Study these statements below and decide if they are a relation or a relation and a function. Place a check mark in the appropriate box if it's true, and if the statement is true for all functions. So, we'll go over this part in class, so you can kind of skip over that for right now. And we'll go over that when we go over independent, dependent, domain, and range on those other few problems. We're also going to go over this part in class, but here's where I want you to start and skip ahead to work on your own, and we'll check those problems. So go ahead and skip over numbers 1, the big chart, A and B. We'll sum that up together, and then I want you to go on to number 2 and the following pages and finish those up on your own. I think you can do that without, and if you want to try to do your conclusions, you can, but I do them in pencil to make sure you can fix it if you make a mistake.